Hey there, this is Mr. Wilford, and I'm going to talk about Chapter 3, Section 6, Solving Linear Systems in 3 Variables. If you remember in the last section, in Section 5, we introduced that new axis, the z-axis, and our new coordinate system um, where we were able to graph three-dimensional points in a plane in 3 dimensions, or at least we attempted to. Again, it can be kind of difficult to do that on a two-dimensional piece of paper. What we're going to do here is talk a little bit about a system of 3 linear equations in 3 dimensions. And if you remember in the last section, we talked about graphing a plane. And if you take not one plane, but 3 planes, and you throw them together and try to find out where they hit, where they intersect, that will be a solution point, and that's what we want to do. Now graphically, this would be a little bit difficult. Let's take a look here at what that would look like. There are really 3 different cases when you have 3 planes that are trying to intersect. You could have no solution, where you have 3 parallel planes. A picture like this, notice that there's some intersection, but not all 3 of them are intersecting together in any of these pictures. You can have infinitely many solutions, and this is where 3 planes intersect, and they actually will intersect in a line. They'll create a line where they all meet. Or this is the case that we want to talk about, where 3 planes intersect and they hit at a point. What we want to be able to do is find that point. Now, we don't want to do this graphically because that would be way too difficult, but we certainly can do it algebraically. So let's take a look at this. And this is a little bit intense here because there are a lot of different equations going on. But if you recall how we did elimination, we're actually going to do 3 eliminations to solve this problem. So we have our 3 equations with 3 variables, x, y, and z. And if you follow this example, we're taking the first 2 equations and we're doing elimination. So we're eliminating the y's. And we add vertically here and here and here. And this is, we get a new equation, number 4. We get a new equation out. Then we want to take another 2 equations. So in this example, we take 1 and 3 and we put those together. Now the y's don't eliminate automatically, so what we have to do is multiply this bottom equation by a -2. Be sure to distribute that -2 to all of these terms. Watch out for negatives, so you end up with this equation here. You can see my y's are eliminated again, they're gone. We add vertically here, here, and here, and that was my second elimination. So now I end up with this equation and this equation, and I'm going to put those together right here. So we have 2 equations with 2 variables, x and z. So I'm going to go to the next page now, and we're going to do our third elimination. And so you need to pick a variable to eliminate. In this example, we're going to say, let's eliminate the x's. So I have a 3x and a -x. Well, what I need is the same number but opposite signs. So I have the negative here, but I don't have the 3, so that's why I'm multiplying this 3 to this equation. And this is what I end up with here. I don't have to change this equation at all. What happens then is my x terms will cross out, add here, solve for z. So z equals -1. Now, remember what we're trying to find here is a point of intersection, and when we talk about a point in 3 dimensions, we're talking about it in terms of x, y, and z. So right now we've only found the z. So what you want to do then is work backwards. We're going to take this -1 and plug it in for z in one of these equations. So actually we substitute it in here, and we can solve for x. Then once we have x and z, we can take both of those and plug it into one of the original equations, and you can see here we end up solving for y. So my final answer here is 1, -3, -1. Alright, please let me know if you have any questions, and thank you.